Greetings. This lecture is on selection and placement. In essence, how do we use assessment tools to decide which candidate is the best and then place them in a particular position in the organization? So our first slide is again the ubiquitous human resource management system model, and you should be looking at that and recognizing that in the implementation box it is underneath recruitment. So after we attract qualified people to our organization, to the applicant pool, we then choose to use all sorts of assessments to decide which candidate will be the best one for the job. So we also work on placing people in terms of deciding which one we'll eventually use and then place them into the position. So given this information, that's how we start the process of getting someone into the organization and making sure that they match what the organization needs to fulfill a position. So our next slide has the two definitions. What is selection, what is placement? And as it says here, selection collects the legally defensible information about the applicants, and then placement is matching them to the particular job. So we'll talk about those sort of simultaneously, but we'll be able to differentiate between how we collect the data and then how do we ultimately make the decision who is the best person for the job. So our next slide. Before we get into this idea of selection tools, which tools we're going to use, how they're going to give us information, we need to know some things behind the scenes about how do we decide which tool is better than another, because there's lots of things out there and we can use all sorts of instruments, but not every tool really gets us into the appropriate information that is, as the definition said, legally defensible, because the key here is we don't want to be using tools that are going to get us prone to a lawsuit. So two concepts that we need to be aware of. One is called reliability. The other one is called validity. Reliability is how consistent a measure is over time or across a number of different judges. Reliability just means we give very consistent information, and validity is how we make sure that the results from the test are able to predict actual job performance, so how accurate it is. So for example, with reliability, I might ask you, what's 2 times 3, and you'll tell me 5. And then I ask you again, what's 2 times 3, and you tell me 5. And I ask you one more time, what's 2 times 3, and you tell me 5. Are you accurate? No, because 2 times 3 is actually 6. But are you reliable? Absolutely, because every single time I asked you, you gave me the exact same result. So reliability is important first and foremost for a measure. It has to give you very consistent results, but it also has to be accurate. So the reliability just makes sure it's consistent. The validity is the element that makes sure that it actually measures what it says it's supposed to be measuring, and that it does it in an accurate manner. Okay, so the next slide, as we get into understanding reliability a little bit better, there are a number of different attributes that we measure when it comes to selection in organizations in terms of matching that person to the job. And some of the kind of attributes we might measure vary in their reliability. For example, physical characteristics like height or weight, they're always very consistent. What I weigh now will probably be what I weigh tomorrow. How tall I am now is probably how tall I am tomorrow. Now, of course, we know over time those things are going to change. For example, the weight I was at 1-year-old is not the weight I am at 50 years old. It's a very different thing. So the difference between the high reliability and the low reliability measures is that the high reliability measures are very consistent over an extended period of time, but not forever. Obviously, we know things are going to change, and what influences things like height or weight, or I'm growing, or I eat too much, or I lose weight because I'm on a diet, or various things like that. These are external factors that influence that measure. But if I were to get on the scale, get off the scale, get on the scale, get off the scale, get on the scale, get off the scale over the course of a day, my weight should be fairly consistent. And the same thing with height. Another thing that's also fairly consistent is abilities and skills. What I can type today, the number of words per minute, is probably the words per minute I can type tomorrow and the next day and the next day. And maybe over time, my typing skills will either improve if I'm practicing, or they might degrade if I'm getting older and my hands can't work the same way that I'd like them to. But the skills can increase or decrease depending on those sorts of things. But that's over a much longer period of time. Within the short run, clerical skills stay fairly the same, whether it's typing skills or alphabetizing skills or numerical order, ranking skills, those basic things. We don't lose those skills over the short haul. And the same thing with verbal ability. My vocabulary today is pretty much the same as it was yesterday or tomorrow. Maybe I learned a new word, but by and large, my vocabulary stays fairly stable. In terms of moderate reliability, this means a lot more things can influence and change my interests, for example. Whereas in the high reliability things, over a very short period of time, very little will change. In the moderate, much more can influence it. For example, if I have interests in certain things, the things I was interested in 2 years ago is not the same things I'm interested in now, or even 5 years ago. It's not the same things I'm interested in now. So our interests will change as we grow, as we mature, as we get to experience all sorts of different things. We definitely notice that these things will change. In terms of the low reliability items, are things like sociability, emotional stability, and cooperativeness. And really, the reason why these are very low reliability is because I could wake up one morning and not be in a good mood, and suddenly I'm not feeling so sociable, or I haven't had my coffee or my tea, and I'm not really feeling very interested in having social interaction with people. I might have had a bad experience with a significant other, and so my emotional stability might be erratic because I'm really unhappy about the situation, and so I'm not feeling very stable. In terms of cooperativeness, I'm not feeling very cooperative. I might be, and again, it might be in a bad mood, or I didn't get along with this team member the last time we worked on a project, so I don't feel cooperative today. So high reliability things, very consistent over a long period of time. Moderate reliability things, over sort of a moderate amount of time. Low reliability things, not so reliable because they can change in an instant. It doesn't mean we don't use these items, because we will test many times for how cooperative someone is or how emotionally stable they are, but we also have to recognize, because they're a low reliability measure, we can't put an enormous amount of weight on those tools. We have to sort of de-emphasize them. They're an important data point, but they're not something that we would want to use over the long haul. When we're assessing reliability, for example, we have the first way we can assess it is what we call test-retest reliability. Test-retest reliability is looking at, how do I take a test the first time, how do I score on it, and then if I retake it not long thereafter, I should be scoring within a particular range. And I've shown two examples here. The SAT is scored out of 1,600 points. And so the first time I take the SAT, I score a 1,000. The second time I take it, I score 1,020. That's an example of a very reliable measure. And in fact, the SAT tends to be fairly reliable, as is the ACT in terms of what it's scoring. Whether or not it's a good measure of college acceptance is a separate issue. But in terms of being reliable, it's very reliable. It would be considered unreliable if the first time you took it, you scored really high, like a 1,200, but the second time you took it, you scored really low, more like a 400. So it sort of varies across the board. So a reliable measure, again, stays within a particular range and give or take some fluctuation. An unreliable measure has massive differences to it, as you see in the second example there. Parallel forms reliability is basically having two forms that are supposed to be measuring the same thing, but they have different questions in them. So you might have two interviewers, interviewer 1 and interviewer 2, who are asking very different questions of your job candidate. And so interviewer 1 says, oh, I highly recommend hiring them. Interviewer 2 says the same thing. I think they're great. I'm going to hire them. And they asked very different questions. Then you're you've got a pretty reliable choice to make in terms of whether or not you want to hire this person. If interviewer 1 says highly recommend and interviewer 2 says do not, then you have an unreliable measure. And when we talk about interviews in a little bit, you'll see when we do interviews, the goal is we want to be asking the same questions. I want to ask the same questions as the next interviewer asks questions, or I want my interviewers to be on a panel so everybody hears the same information, the same answers all at the same time. And this way, we increase the reliability of that measure so that we will get consistent results in terms of hire or not hire. But when we use different questions, if I ask a certain set of questions and you do, we are more likely to have unreliable measure in this situation. But just as an illustration of what parallel forms mean, you have to have agreement between the two forms or the two interviewers in order for it to be considered a reliable measure. Internal consistency reliability is basically how how things like the SAT or the ACT or other instruments that ask a large number of questions can give you a subscore of this is your verbal score, this is your math score, this is your reading score, and it gives you a sense of the types of questions that are asked are all related to each other in some way, in an internally consistent way. And for example, you have a synonym for charisma, an antonym for rational, and defining the word extrapolate. This is all getting at language skills or verbal skills. And so I could see how you score on that, and then I could come up with a measure that says your score on this verbal test is good, and therefore you pass the test and I will hire you, or you did not score well and therefore I won't hire you. So there's a measure of how those things are correlated or related to each other, and we use the term coefficient alpha or Cohen's alpha that gives us a measure of how consistent those scores are. An unreliable measure is one that asks a question, for example, the square root of 1024, and then it asks you when the Boston Tea Party took place, and then it asks you what the capital of Brazil is. And as you can see, there's no consistent way to group those questions together. They're all important things that maybe we need to know, but they are not necessarily related to each other. One is a math question, one is a history question, one is a geography question, and because of that, I can't score them all together and have a subscore that says you scored well in something, because I have nothing to base it on. I can't say it's a good score in math because there's only one math question. I can't say it's a history score because it's only a history question, and I can't say it's a good geography question because it has things that are not asking about geography. So if you're going to have a subset score like that, all the questions have to be related and correlated to each other. So those are the examples of how we can assess reliability. And when we have a measure that has a lot of questions, we want it to be internally consistent in terms of its reliability. Once we've determined that something is reliable, it's going to be consistent results, then I need to work on how to get it to be accurate. So there's a couple of different ways we can do this. There's a multitude of ways actually, but the two ways that are most important and are also required by law are content validity and criterion related validity. There's a third category which we won't get into, but these two for sure are important in the context of what we do every day in HR. So content validity, to start with, is that the content of the test actually equals the content of the job. So for example, if the job required you to be able to mop a floor and dust a room, I would have you, the test I would give you is to see how well you mop the floor and dust the room. So the content matches. And if you do well on the test, clearly you do well on the job. And so that content validity is an important connection. Then we have criterion-related validity, where we want to know if the independent variable, the criterion, actually predicts the outcome that we want, the performance outcome. So a couple of different ways we can do this. One is concurrent and one is predictive. Concurrent validity, if you go to the next slide, is about measuring something at the same point in time. So if I give you a test to take right now and then I correlate it with your college GPA, I should see consistency. So, for example, let's say I sit you guys all in a room, I have you all take the SAT right now, and then I do a correlation with your college GPA right at this moment, whatever it is. Then I should see a high correlation between how well you scored on your SAT or your ACT and what your GPA is. And that would mean it's a good concurrent validity predictor. It's not a good predictor if you scored really low on the test or really high, but your GPA doesn't match it. So for example, if you scored really high but you have a low GPA, or vice versa, you scored really low but you have a high GPA. So that tells me that as a concurrent predictor, it's not very good. How does this apply in a business organization? Well, what I would do is I would create a measure. Let's say I have a new measure for how well someone can do math. And so I'll come up with a number of questions and a range of questions that I expect people to be able to know how to do a particular job. Then I would go and I would give it to everybody who in my organization who would need to take that test if they were applying for the job, have them all take it and see how well they score on that test. Sounds great. Then I would correlate that with how well they're doing on the job. So I would compare how they did in the test in this moment, today, and compare how well they did on their performance appraisal, because it should be able to be a high relationship between the two. Here's the challenge of doing a concurrent validity. Think about it this way. If I'm going to give a test to everybody in my company, I'm going to expect, for the most part, that most, if not all of them, are going to be good performers, at least meet the minimum standards that I need to be in the organization. So this test that I'm creating will be correlated with good performers. So it will do a really good job of telling me who is going to do a good job on it, and I know that it can predict good people. What it doesn't tell me is whether or not it can predict people who would be poor performers. So it predicts the good performers because I have good performers in my company, and that much I can know. But because I shouldn't have bad performers in my company, I don't know whether or not this test can predict poor performers. And it might only be able to be good at good performers. It may not be able to differentiate poor performers, which can be a problem. So we can use predictive validity to do that, and it works in a slightly different fashion. What I might do for someone who applied to my college, they took their SAT in '95, they then entered the school in 1996, they performed for a couple of years, and then I compared their GPA in 1998 to how well they did in their SAT. So I want to see, did those SAT scores actually predict how well someone could do? And the first example there is a mid-range SAT score and a pretty good GPA. So that shows me that it can do a pretty good job of predicting. The bad predictor is if I took the test ages ago, I scored really well, but I'm doing very poorly in college. And that's saying that that's a very poor future predictor of how well you're going to do in college. How does this relate to the business organization? Well, the same sort of situation. Let's say I want to design this new test. Instead of giving it to my existing employees in the company, I give it to everybody that I'm thinking about hiring over the next couple of months. Now, I might not use that information to make the hiring decision because it's not validated yet, but I'm going to collect that information and I'm just going to set it aside in a database. And I'm going to use my existing criteria to hire everybody in and make decisions to hire or not hire. So now I've got a range of scores from people that I didn't hire and may have done very poorly on it to people who I did hire and may have done very well. And then I want to correlate how well they did on the original test that I gave them, and whether or not they're working for the company. So when I'm making my hiring decision, I have people that I decided to hire and people I didn't decide to hire. And the assumption is the people I decided to hire should have scored really well on the test. The people I decided not to hire should have scored more poorly on the test. And that's how I can demonstrate whether or not I've done a good job of predicting into the future how well someone would do on the job. And so that's what we're looking for in terms of those kinds of decisions. So the next slide, how do you know a selection tool is measuring accurately and reliability? This is a great example of that. And I'll go into this in more detail in class because it's sort of hard to describe in just 2 dimensions, right? But in the upper right-hand quadrant is someone who did really well on the test and was predicted to be a good job performer. And the lower left-hand quadrant is someone who failed the test and also did not do well. And when we do predictive validity, that's what we would love our graph to look like, or our chart to look like. We should have people in the pass the test, high job performer category, and then we should have people who failed the test in the low job performer category. And that should work out that way as a very good, strong, positive correlation. And I'll talk about sort of how do we decide where that cutoff score goes when we get into class, because it's important that you understand how we can move that cutoff score if it's too high or it's too low. This is how we can sort of start to get at how do we get a cutoff score that makes sense so that we don't have adverse impact, as we were talking about earlier in the term, and also that we're getting maximum ability to predict a good performer on the job. So that's how we sort of conclude this issue of reliability and validity, and we'll get into some of these, we'll get into this 2x2 matrix when we get into class next.